Okay, this is section 11.4. This is the area of regular polygons and composite figures. We have talked about regular polygons before. Just remember, a regular polygon is when all the sides are the same of that polygon. Composite figures, those are going to be figures where we basically combine multiple polygons into one picture. And so you'll get the area of different parts and then you'll add them all up. And so there's going to be one area formula that we can use for all of these. Now we're even going to see a square is a regular polygon, or an equilateral triangle is an equilateral polygon. And even though there are different formulas you can use specifically for those things, you can also use this formula for those things as well. And so we'll look at that here on the next slide. I would say if there were a difficult part of this unit, this would probably be the most difficult. So make sure that you really understand all of this. So the area of a regular polygon, the formula that we are going to use is this one here. And so it's 1/2. Okay, so the big A, that's going to be area. So you've got area equals 1/2. The A, you're going to see here in a little bit, we'll define all these things. A is going to be your apothem. Some people say apothem, apothem. I don't really know the exact way to say it. The big P is going to be your perimeter. I definitely just spelled that wrong. Perimeter. Wow, I really spelled that wrong. Don't write that down. Let's try this again. Perimeter. Okay, sorry. There's a reason I teach math. Okay, so you're going to take 1/2 of the apothem times the perimeter. And so if we look at this polygon down at the bottom, so if we look down here, we're looking at this circle and we have a regular polygon, a regular pentagon to be exact, inside, inscribed in this circle. And so within this we'll have the center, which is going to be P. Okay, and then we get into this term that you haven't really seen before, and this term is called the apothem. So the apothem is going to be the line or a segment that's drawn from the center to the midpoint of the side of the polygon. So it's a perpendicular segment. It doesn't really have this definition anywhere, so you either may want to write it and just make sure that you really understand it, but that your apothem is going to be the segment drawn from your from your center to the midpoint of your side. Okay, and so here in this case our apothem is PF, segment PF. Okay, your radius is still just your normal radius that we've seen before. And so our radius here is going to be coming from the center into the vertex of your shape of our pentagon here. And so our radius here would be PA. And then the central angle here, the angle that's coming from the center, so this angle here, that angle we would name as angle APB. Okay, and there's going to be a lot of different steps that goes into this, because sometimes you're going to have to find the apothem, you may have to find the radius, you may even have to find the side. So there's kind of a lot that goes into it. What we're first going to start with is you're going to see all these triangles drawn on these first basically 6 shapes that we're looking at. And we're just going to break these down a little bit, and then you'll get to the point where you won't have to look at anything like this again, but we're just going to start out slowly. So just assume that you don't know really anything about an equilateral triangle. Like right now, you could tell me what each angle is. Everybody could tell me that since they're all equal. But just assume that you don't know that, okay? And that we're going to think about this formula that I've given you today, the 1/2 apothem times perimeter. Okay, so let's think back to what we know about interior angles and exterior angles. So interior angles, there was the formula that we used, that was the 180 times n minus 2. Okay, that could help us here, but then we'd have to do some extra steps, and I'm just going to make this easy. What I like to do is go ahead and figure out what each exterior angle would be. So if I extended this line outside the triangle, if I did 360, so remember that all the outside angles of any polygon always add up to be 360. So I can just stay consistent with that number on all of these shapes. So if I do 360 divided by 3, then the exterior angle is 120. Okay, well if the exterior angle is 120, then the interior angle is 60. So these are all 60. Okay, so here's what we're going to think about. So now if I were to draw in a radius, so if I draw in a radius and I draw in an apothem, again, remember that apothem is just that segment that's drawn to the midpoint of the side perpendicular line. What we now have is when I've drawn in that radius, this little angle here is 30. Okay, we know this one is 90, which means that one has to be 60. And so when we come down to this triangle down here, I'm just going to fill in those numbers. So this is 30, 60, 90. Okay, and so since it's a 30, 60, 90, here's our apothem, here's our side, and here's the radius. And so what this A means, that's just your apothem, R means your radius, and 1/2 S, that's because this piece here is 1/2 of the side of the triangle. So that's where all those things are coming from. Okay, this is going to be important because it's going to help us find numbers here in a minute. Okay, but right now we're just talking about what those interior angles would be. Okay, so if we come to a square, okay, yes, obviously a square, we know what all those angles are, but I'm just going to keep this consistent. So 360 divided by 4. Remember, I'm using 360 because that's what all the exterior angles add up to be. That would be 90. So if I drew in an exterior angle here, that would be 90, which means the inside is 90 because they need to be 180. Okay, well now if I draw in this triangle, again, remember, you are going to have to draw a triangle every time, but you're not going to have to come down here and redraw it, but we're just going to do it for the time being. So if I draw in that radius, this angle now here is going to be 45, which means the other angle is 45, and now we bring it back in our 45, 45, 90 rules. Okay, and so that's why those rules definitely are not going away this unit. Okay, so now let's look at here we have a pentagon. Okay, so if I were to put my center here, and I'm going to go ahead and draw in a triangle. Okay, so what we need to do is figure out what every interior angle of this pentagon needs to be. So I'm going to do 360 divided by 5, and that is going to get me what every exterior angle needs to be. So if I do 360 divided by 5, that is 72. So if that's the angle on the outside, then the angle on the inside would have to be 108. Okay, and so what we're doing, when I just drew this triangle here, if the whole thing was 108 and I split that in half, this angle is now going to be 54. We have our 90, and then if we do 180 minus those things, we have 36. Now remember, we don't have any special rules for a 36, 54, 90 triangle, but these are going to be the instances where you're going to have to use trig. So just realize that. Okay, then we come over to a hexagon. Okay, and what I'm going to do, I'm going to do 360 divided by 6, so I can get every exterior angle. And so if the exterior angle is 60, then when I draw, so the interior then would be 120. And so when I draw in my triangle here on the inside, okay, this angle would be 60, this would be 30, and 90. Okay, and this will help us find our apothem and radius and sides later. Okay, this next shape, it looks like we have 7 sides. So I'm going to do 360 divided by 7. And if you do 360 divided by 7, it is not a nice number. So when you subtract that from 180, you get like 128.57. And if you divide that by 2, you get about 64.286. and then that would leave this to be 25.714. We won't give y'all a lot with 7 sides. It'll be more of these other ones. But again, if you see those funky numbers, you know you're probably going to have to do trig. I forgot to draw that triangle in. Okay, then we come over to, we have an octagon. So I'm going to do 360 divided by 8. And 360 divided by 8 is 45. Okay, remember what we're finding there. That's the outside. That's the exterior angle. So if I do 180 minus 45, that gets me 135. So when I draw this triangle in, this angle is 135 divided by 2, which would be 67.5. And that would leave this other angle to be 22.5. Okay, and again on this, when you see those funky angles, you're going to have to use trig. Okay, so the first battle in these is just figuring out what those angles need to be. And so when you see these, with these first 3 that are all equilateral triangles, I don't really need to go through all of that trouble because we already know that each one of these angles is going to be 60. Okay, and so whenever we draw in our triangle, okay, I now know that this angle here is going to be 30, so this angle up here is going to be 60. So I don't really need to redraw that anywhere like we saw in the last couple of slides because I have it right here. Okay, so here's what we're going to do. We need to do area equals apothem times perimeter over 2, or you can do 1/2 times apothem perimeter. It doesn't matter. Now, there is another formula for equilateral triangles. We saw that on the first day, so you can use that as well, but you're still going to have to find the sides. So either way, you're going to have to find the sides. But just to kind of reinforce this formula, I'm going to keep using this formula for today. Okay, and so the apothem, we actually do know the apothem. Okay, that's the 2. To be able to get the perimeter, we need to know the side. And so what we do know is that this is a 30, 60, 90. And where the 2 is, that's my x. And this would be my x root 3 side. Okay, and so that piece right there, if x is 2, then that would be 2 root 3. And then this piece would be 2 root 3. So the entire side is 4 root 3. So every side is 4 root 3. So if you get the perimeter, so 4 root 3, 4 root 3, and 4 root 3, that would be 12 root 3. Okay, and this one's really easy because those 2's can just cancel out. And so our area here is 12 root 3 units squared. There we go. Hopefully that wasn't too much of a jumble. If it was, we've got 2 more like it coming up. Okay, so again, this is going to be a 30, 60, 90, okay, because that whole angle was 60 and I sliced it in half. Here the information they give us is that the side is 18, okay, and so this piece down here is going to be 9, okay, because it's going to be half of 18. Now this one requires a little bit more work because if I want to do apothem, I don't have that yet. We do have the perimeter. Okay, the perimeter here would be 18 times 3, which is 54. Okay, but we need to find the apothem. Okay, so this one requires a little bit more work because the side that we're given here is opposite the 60. And that, we all know, hopefully, is our x root 3 side. So I'm just going to solve this. I'm going to say x root 3 equals 9. Now I'm going to have to divide by root 3. Okay, now I'm going to rationalize this to get rid of that root 3. And when I do that, that gets me 9 root 3 over 3. And then 9 over 3 goes down to 3 square root of 3. And so that is my apothem. That's what we've just solved for as x right there. Okay, And so we have 3 root 3 times 54 over 2. Okay, and so now that I have all that, you know what, I'm just going to write this up top. So 3 times 54 divided by 2 is 81. So our area here is 81 square root 3. Now on this one, since they gave you the side, would it have been easier to use the equilateral formula? Yes, it would have been. But again, we're just practicing this stuff. All right, so this next one. So again, I need to do apothem times perimeter over 2. So we're going to see if we have any of that. Okay, I don't have the apothem and I don't have a side, so I can't get my perimeter. And so what we need to do here is see what we do have. Okay, we do have the radius. And again, this is a 30, 60, 90 triangle in here because we're still looking at a equilateral. Okay, so that is my 2x side. So if I want to know x, I'm just going to divide that by 2. And so x here is 4 square root of 3. Okay, that is our apothem. So I can kind of start filling that in. So that's 4 root 3. We still need the perimeter over 2. Okay, so now to get the perimeter, I need to find this other side of that little triangle. Okay, so to get that, we need to take x, which is 4 root 3, and multiply it by root 3. Okay, so that would be 4 root 3 times 3, so that would be 12. So that's this piece. So the entire side would be 24. So it'd be 24, 24, and 24. So when you do the perimeter, you get 72. So now when you do 4 times 72 divided by 2, you end up getting 144 square root of 3. And again, I keep forgetting to put units squared on all of these, but we are talking area here. Okay, lots of examples. Okay, so find the area of each irregular polygon. So here, obviously, we have squares, and so you can do this just using a parallelogram formula or square formula, but I'm going to do a little bit more with it. So area equals apothem times perimeter over 2. Okay, they tell us the side here is 10. So all the sides are 10, which means we do know the perimeter is 40. Now I need the apothem. Okay, so to find the apothem here, I'm going to look at this triangle and I'm going to say, okay, this whole angle was 90. And so now that angle, we've got a 45, 45, 90. Okay, if the whole side is 10, that means this piece is 5. Okay, well that means the apothem is also 5 because this is a 45, 45, 90. So I'm going to plug that 5 in for apothem. So area equals, that'd be 200 divided by 2, which is 100. Which makes sense because 10 times 10 is 100. Okay, number 5. Again, I'm sure you are getting annoyed by me writing this formula down every time, but it's really important, especially when we get into the next unit where we have a lot more formulas. It's going to be important to have that every time. Okay, so here let's see what we have. We do have the apothem is 9. We do not have the perimeter yet. Okay, but if that side's 9, then this side's also going to be 9 because it's a 45, 45, 90. Okay, which means the entire side is 18. So all the sides are 18. And 18 times 4 is 72. 72 times 9 divided by 2 is 324. Okay, number 6, here they're giving you the radius. So we do not have a side or the apothem yet. Okay, and so that is your x root 2 side in your 45, 45, 90. The good thing is that has a root 2 on it, which means x is just 1. Okay, so our apothem here is 1. Okay, well if both sides are 1, that means the entire side of the square is 2. So you've got 2, 4, 6, 8. So 1 times 8 divided by 2 is 4 units squared. again, when you figure out that that side's 2, you could just do 2 times 2, and that gets you the area of the square. Okay, now we're getting a little bit more difficult. So here we have a hexagon. And so what I would have to do first is 360. So this is something I don't know off the top of my head. 360 divided by 6 is 60. So the exterior angle is 60, which means the inside would all be 120. And when you divide that by 2, that angle would be 60. Blow this up a little bit more. Okay, so that would be 60, which means this angle is 30. So when I want to start doing apothem times perimeter over 2, let's see what we have. So we do have the apothem. That's 4 root 3. We do not have the perimeter, so that's what we're missing. Okay, and so here, if that 4 root 3 is across from 60, that's because that's my x root 3 side. And the good news is that already has a root 3 on it, so x is 4. So that's my short side of that triangle, which means the entire side of the hexagon is 8. So all of the sides are 8. And if you do 8 times 6, you get 48. So 4 root 3 times 48 divided by 2, you would get 96 square root 3. Okay, the next one. So here it says that the radius is 15, although this picture is showing it's 16. So we're going to say it's 16, because I know that 16 works better. Okay, and so again, I would do the same thing, but we already just did it on the problem before. So this is 60 and 30. Okay, that is my 2x side, which means my short leg here is going to be 8. And so my apothem would be 8 root 3. So now I think we have everything we need. So we have apothem, which is 8 root 3, times perimeter. Okay, if that piece is 8, then the entire side is 16. So 16 times 6 is 96, divided by 2. And if you multiply all that, you get 384 root 3. Okay, so they're not all hard, I promise you. Okay, so here I'm going to draw in a triangle because there's not one drawn. And they tell me that the perimeter is 120. So if I do 120 divided by 6, that means every side is 20. But all I really care about is when I get around to my triangle. And so that would be half of the side, which would be 10. Okay, that's my short leg. This would be 10 root 3, and we don't really need the radius here, but it would be 20. Okay, so now we have everything we need. So the apothem is 10 root 3 times the perimeter, which they gave us, is 120 over 2. And when you multiply all that out, you get an area of 600 root 3. All right. So here we go. So now we have, you know what, I may just do one of these because you're going to do the same thing on both. So find the area. Here we have a pentagon. So if I do 360, you have to figure out what these triangles, what these angles are in these triangles first. So I'm going to do 360 divided by 5, and that is 72. So the outside angle is 72, which means the interior is 108. So this little angle in here, in this triangle, this one right here, is going to be 54, which means this angle is 36. Okay, again, we're trying to get the area. So let's see what we do have. We do have the apothem as 11. What we don't have is the perimeter. Okay, so we need to get that, which means we need to find this side. Okay, you can use either one of those angles that you have. I'll just use the 36. And so from so here we're going to have to do trig. I think y'all already figured that out. So I'm going to use that angle. So opposite is what we're, opposite is what we're trying to find. and adjacent is what we have. So if we have opposite and adjacent, that would be tangent. So I'm going to say tan of 36 equals opposite, which is x, over adjacent, which is 11. Make sure you type this in your calculator and just check it and make sure that I have the right number here. So if I do 11 times tan 36, you get about 7.992-ish. Okay, now think about what we just solved for. That was just this little piece. Okay, so I'm going to keep that in my calculator and I'm going to double it. Okay, so I can get the entire side. And you have about 15.98. Now I need to get the entire perimeter, so I need to do that times 5. And when you do that, you get 79.91. However you want to, well, 92. 2. So again, what I did was I typed 11 times tan of 36 in. That got me this little piece of the triangle. I doubled it to get the entire side. And then I did it times 5 to get the perimeter. And when you do all that, you get an area of about 439.558 units squared. If you want to work through number 11, you will have to do trig again there. And if you just want to check that, I can give you the answer. The area is 649.487. So if you want to try that one and pause the video and check it, then you can do that. Okay, and then we come to our last question. Thank goodness, because this is a long one. And this is a composite figure. That's just when multiple polygons are thrown together and you want to get the area of all of it. The best advice I can give you here is to break it down as much as possible. And so look at the 3 shapes you have and be very specific with those. So let's just start with the far left. So we have a half circle here. So what I'm going to do is get the area of the half circle. I just kind of like to write this out so I can keep things separate. So area of a circle is pi r squared. Okay, and so I'm going to do pi times r. Okay, so let's see what r is. They tell us that these sides are all 9. So the whole side here is 9. So our r is going to be 4.5. So that's 4.5 squared. So pi r squared. And then if we want half of it, we're going to divide it by 2. So when we do that, we end up getting, and I'm just going to keep this as nice as possible since we're going to be adding these all up, but this would be 81 over 8 pi. Okay, so that is the area of the circle. So now we'll move to the shape on the inside. Okay, and this is a hexagon. Okay, so here we're going to use what you learned today. Okay, and I'm just going to erase that stuff. And so what I'm going to do is I'm going to take one of these sides and I'm going to draw in my triangle. Okay, now you can go back to what we did before, but we would do 360 divided by 6 would be 60. That would be the outside angle of this hexagon. So the inside would be 120, which means what we've now created is 30, 60, 90s in here. So this is going to be the area of the hexagon. Is going to be apothem. Okay, we do not have the apothem. What we have is a side. Okay, if the whole side is 9, then this piece is going to be 4.5, which means our apothem is going to be 4.5 root 3, because it's a 30, 60, 90. So I'm going to have apothem, which is 4.5 root 3, times the perimeter, which would be 9 times 6 is 54, over 2. And when you do all that, you get 121.5 root 3. Okay, and so that is our hexagon, area of our hexagon. Okay, and the last part, we need to get the area of, what is this? This is a trapezoid. So area of a trapezoid, going back to that formula, is you need to take the height. And the height they're showing you up at the top is 19. Then you add your bases. Okay, we have one base of 9 and one of 15. So 9 plus 15, and you divide it by 2. And if you do all that, we get a nice number of 228. So now, when you add all of those up, and we're just going to keep this as exact as possible. And so if we wanted exact, it would be 81 over 8 pi plus, you could either say 121.5 root 3, or you can put it as a fraction. That would be 243 over 2 root 3 plus 228. If you wanted the decimal answer, you just add all those up. But honestly, it's easier just to keep it like this, because then you don't mess anything up when you're typing it in. So, sorry, I know that was very long, but I wanted to be extra careful and specific when talking through this because it can be very confusing.